Hello everyone. In this lecture, we are going to discuss about a non-deterministic PDA, construction of non-deterministic PDA for the language W reverse such that W is in 0 plus 1 to the power plus. That means W is made up of zeros and ones. So at least one symbol from zeros and ones is followed by reverse of W. So 0, 1, 1 is W, means it should be followed by W reverse 110. So it is a even length palindrome. So and one more example, 110 followed by reverse of W is 011, right? So if we want to construct a PDA for this in a stack, consider the first example. Here the bottom of the stack is Z0, so half of the input symbols must be pushed onto the stack. So 0, 1, 1 should be pushed onto the stack, and for the remaining half, for each symbol it should be matched with the top of the stack, because the next input symbol after pushing the first half of the input symbols, this is the configuration of the stack. Next input is 1, it is matched with 1, so it should be popped. The next input is 1, top of the stack is also 1. Next input is 0, top of the stack is 0. So if we reach Z0, we can go to the final state. So similarly, the starting symbol may be 1 also, right? So 1, 1, 0 should be pushed onto the stack, and for this 0, 0 is popped, 1, 1 is popped, 1, 1 is popped. So this is the concept here. So we have to construct a PDA for this. So delta of Q naught is a current state, and current input symbol is first one. So I'll write the first input string here, and this is the stack for first example, and I'll write the second input here, and this is the stack, because here W is made up of zeros and ones. So delta of Q naught comma, the first input symbol may be either 0 or 1, right? First input symbol may be either 0 or 1. So there are two transitions we need to write. So if we are in state Q naught and the current input symbol is either 0 or 1, so two transition. If the current input symbol is 0 and the top of the stack is Z0, okay, means we need to go to the state Q naught, that is we should remain in the same state Q naught, and 0 should be pushed onto the stack. So we have to write like 0 Z0. This Z0 replaces Z0, then 0 is pushed onto the stack in this case. And here also we should remain in same state Q naught, and 1 should be pushed onto the stack here. So 1 Z0. 1 is pushed onto the stack now. Now after pushing 1 0 or 1 1, the top of the stack may be either 0 or 1, right? So current state is still Q naught. So Q naught is a current state, and current input symbol, again the next input symbol may be either 1 or 0. Either 1 or 0. Okay, I will make 0 here. So 1 0 0 means it should be followed by 0 0 1, right? So 0 0 0 1. So the next input, first input is either 0 or 1, second input symbol also either 1 or 0. So current input is either 1 or 0. So first assume this. So current input is 1 and the top of the stack is 0. Current input is 1 and the top of the stack is 0, means we should remain in same state Q naught, and this 1 should also be pushed onto the stack, right? So we have to write like this, just combine and write 1 0. This 0 replaces 0 and 1 is pushed onto the stack. So sometimes 0 may be the 0 may be the top of the stack, and 0 may be the next input symbol. Next input symbol can also be 0, right? So in this case, the next we should be in the same state Q naught, and 0, this 0 should also be pushed onto the stack, right? So the top of the stack may be 0 and the current input is either 1 or 0. So in both the cases we need to perform, we have to insert that symbol, so that we have to combine and write. And now the top of the stack may be 1, right? and the current input symbol is either 0 or 1. So 0 means we should remain in same state Q0, and 0 1. So we have to push. So 0 is pushed onto the stack in this example. Okay. Similarly, the current input is we are in state Q0 and top of the stack is 1, and the next input may also be 1. So in this case also we have to push. Okay. So that so in both, so first two steps are pushing 1 0 and 1 1. That is, first two steps are pushing one symbol onto the stack, and this is the recursive step for pushing any number of zeros and ones onto the stack. Okay, so 1 0 0 0 0 1 1 1. There are 4 possible combinations. So in all the cases, top of this stack may be either 0 or 1, and the current input symbol also may be either 0 or 1. In these cases we need to perform push operation, and there is no change in state here. So here see, in this example, the next third input is 1 and the top of the stack is 1, right? So Q0 1 1, current input 1, top of the stack 1. So state remains in Q0 and 1 is pushed onto the stack. And in this example, next input is 0, top of the stack is 0. So Q0 0 0, we should remain in the same state Q0 and 0 is pushed onto the stack. So now we are in the middle of the string, right? Half of the inputs are pushed onto the stack. So we are in the middle of the string. So next we need to perform pop operation, right? So just we need to change our state from Q0 to Q1 without consuming the input symbol. So delta, this is first operation. Second one is delta of Q0 comma, the current input, we have to consider the current input is epsilon, and top of the stack may be either 1 or 0, right? So delta of Q0 comma epsilon comma 0 is the current top of the stack, means we need to go to Q1 and no change in stack. Just we are changing our state from Q0 to Q1, so we are not considering any input, and the top of the stack also not changed. Then Q0 is the current state, epsilon is the input, and 1 may be the top of the stack. So here also we have to go to Q1 and 1. 1 is the stack content. Okay, there is no change. So now I'll write here. Now the third step is delta of Q0 comma, now we are in state Q1. So in Q1 the next input is either 1 or 0. Okay, but in both the cases top of the stack should also be same. So here the next input is 1, top of the stack should be 1, next input is 0, top of the stack should be 0. So in Q1 0 is the current input and top of the stack is 0, means we should remain in the same state Q1 and pop operation should be performed. So there are two cases, current input may be 1 or 0. So if the current input is 1 and the top of the stack is also 1, means we should remain in the same state Q1 and pop operation is performed. So here 1 and 1, so pop operation is performed. Then next symbol is also 1. Next input is 1, top of the stack is 1. So we should remain in the same state Q1 and this 1 is also popped. Next input is 0, top of the stack is also 0. We are in state Q1. So Q1 0 0. So this 0 is also popped. So in this case current input is 0, top of the stack is 0. So this is executed. So 0 is popped. Next input symbol is 0, top of the stack is also 0. So this transition function popping this stack. Then for next input 1, top of the stack 1. So we will be in the same state Q1 and this 1 is popped. So now in both the cases the top of the stack is Z0. Okay, so the final step delta, current state is Q1 and we have consumed all the input symbols. So consider epsilon. So epsilon is the next input and top of the stack is Z0, means we have to go to the final state Q2 and empty the stack. So PDA, P can be written as Q0, Q1, Q2. Input symbols are 0 and 1. stack symbols 0, 1, z0, 0, 1, z0. Delta is a transition function that we have listed here. Q0 is a current state. Z0 is a starting stack symbol, and Q2 is a final state. Now we will draw the transition diagram for this. So Q0 from Q0 to Q0, from Q0 to Q0 we have to write 6 transitions, right? So 0 comma z0 slash 0 z0, 1 comma z0 slash 1 z0. I'll write the remaining here. 1 0, 1 comma 0 slash 1 0, 0 comma 0 slash 0 0, 0 1 slash 0 1, 1 comma 1 slash 1 1. Next we need to draw the transition from Q0 to Q1. So epsilon comma 0 slash 0, epsilon comma 1 slash 1. Then Q1 to Q1, there are 2 transitions, 0 comma 0 slash epsilon, 1 comma 1 slash epsilon. Then from Q1 to Q2, epsilon comma z0 slash epsilon. Actually this problem is an example for non-deterministic PDA, because here we are assuming that after reading 3 symbols we are in the middle of the string, but in each and every case we have got the choice, right? So after pushing in this example, suppose 0 1 1 1 1 0. So in this example, after pushing 0, right, after pushing one symbol 0, because for the first time z0 is top of the stack, right? Q0 is a current state, 0 is a current input symbol, z0 is a top of the stack. So Q0 comma 0 z0 is only one case. So we will push 0 onto the stack. But the next for the next input, what is the current condition? Q0 is the current state, 1 is the input symbol, and top of the stack is 0. So Q0 1 0, right? Q0 1 0. So if we consider this transition Q0 comma 1 comma 0, then we will perform push operation. But we can also consider this transition, because without considering the input also we can go to the next state, right? So here epsilon can be considered. So Q0 epsilon and 0 is the top of the stack. So Q0 epsilon 0, if we consider this transition, then we will go to the next state, right? So at each and every symbol we have to take a decision. So whether to perform push operation, or we need to go to the next state to perform the pop operation next. So this is an example for non-deterministic PDA. We will consider the string 00 or 00. This is the palindrome string, right? Here W is 00 and W reverse is also 00. So this string must be accepted by our PDA. So we have to start with the start state Q0, and in instantaneous description we have to write the state string comma the bottom of the stack Z0. Then Q0 0 Z0. So we have to consider Q0 0 Z0. Q0 0 Z0 has only one possibility. So it goes to the same state Q0, and here 0 is considered in the input, so it should be removed from the input string. So the remaining string is 0 0 0. Then Z0 is replaced by 0 Z0. So this Z0 is replaced by 0 Z0. Then in the next condition Q0 0 0. So Q0 0 0 means we can consider this transition, or we can consider Q0 epsilon 0. Q0 epsilon 0. So there are two possibility. So we may get two cases. One is if we consider this path, then Q0 goes to Q0. Then 0 is given considered as an input, so it should be removed from the input string, and 0 on top of the stack is replaced by 0 0. So 0 is replaced by 0 0 z naught. Then here, but if you consider this path here, q naught epsilon 0, so it goes to q1, and epsilon is considered as a input, so it is no change in input string, so 000, and 0 is replaced by 0, 0 is replaced by 0, so no change. Then q naught 0 0, q naught 0 0, or we can consider q naught epsilon 0. So here also there are two possibilities. We may consider q naught 0 0, so it goes to q naught, and 0 is considered as the input, so it should be removed from the input string, and 0 is replaced by 0 0. So the top of the stack 0 is replaced by 0 0. This 0 z naught we need to write as it is. Then another possibility is we can consider q naught epsilon 0, so it goes to q1, and epsilon is considered, so no change in input string, and 0 0, the 0 is replaced by 0, so no change here. So if we consider this path, q1, so this we will complete it later. So now q naught 0 0, so q naught 0 0, either we can follow this or this method, this transition. So there are two cases. Q naught 0 0 means it goes to q naught, 0 is considered here, so epsilon it is it should be consumed, then 0 is replaced by 0 0, so 4 zeros z naught. This is one condition, one transition, one move. Another move is q naught epsilon 0, so if we consider this, then q1 and epsilon is considered, so no change in input string, then 0, top of the stack 0 is replaced by 0, so no change in top of the stack. Then here q naught epsilon 0, q naught epsilon 0, only one possibility, so we have to go to q1, and epsilon is considered, so no change in input, and the 0 is replaced by 0, so no change here. Now we have q1 epsilon 0, q1 epsilon 0, but from q1 there is no transition like q1 epsilon and 0, so this path is wrong. This path ends here, okay. So and q1 is not a final state, input string is fully consumed, but q1 is not a final state, and stack content is not empty, so we cannot follow this. Then if we expand this, then q1 0 0, q1 0 0, q1 0 0 means next state is q1, 0 is consumed, and this 0 is replaced by epsilon, so 0 0 z naught. Then q1 epsilon 0, q1 epsilon 0 is not a transition like this, so this path also ends here. Then q1 0 0, q1 0 0 means this path can be expanded like it goes to q1 only, then 0 is consumed from the input string, and this 0 is replaced by epsilon, so 0 z naught. Then q1 0 0, q1 0 0, again q1, and 0 is consumed, and this 0 is replaced by epsilon. Now q1 epsilon z naught, so q1 epsilon z naught means it goes to q2, no change in input, and z naught is replaced by epsilon. So now we reached q2 epsilon epsilon, okay. So here in this path we have reached final state q2, input string is fully consumed, and the stack is empty. And if we expand this path q1 0 0, so q1 0 0 means again we will get q1 0 0, here q1 0 0 means it goes to q1, 0 is removed from the input string, 0 is consumed, the top of the stack 0 is replaced by epsilon. So Z0. Then Q1 0 Z0. Q1 0 Z0, there is no transition like that, but if we can consider Q1 epsilon Z0, so it can reach Q2, and epsilon is considered, so no change in input string, and Z0 is replaced by epsilon. Here we can say that we have entered into the final state Q2, but input string is not fully consumed. So PDA accepted by final state means it should enter into the final state and input string should be fully consumed. Or PDA accepted by empty stack means the stack should be empty and the input string should be fully consumed. So in both the cases, input string must be empty, epsilon. But here it is not like that. So the correct path is this one. So we have to follow this path. So this is the informal representation. We have to write instantaneous description for proving the string is accepted. Okay, so here if we see 2 zeros are pushed onto the stack. After pushing 2 zeros onto the stack, then pop operation is done. So that at least in one way it enters into the final state. So this is the non-deterministic finite automata. In more cases we have the decision. We have to choose with choices. We have to choose whether this path or that path. So this is called as non-deterministic finite automata. The correct way of writing this one is Q0 4 zeros Z0 instantaneous description, Q0 triple 0 0 Z0, then Q0 double 0 00 Z0, Q1 0 0 0 0 Z0, and Q1 0 0 Z0, Q1 epsilon Z0, and Q2 epsilon epsilon. So 2 zeros are pushed onto the stack, then pop operation is done. So that we can say that this input string is a even length palindrome. Thank you.